Hello class, are you hearing me? Good. I apologize, I'm a minute late. I have back-to-back classes on Monday, Wednesday, and sometimes I get confused about the links. So I log into Zoom and I clicked on the first one, and it seems that it's still my previous class. So this is the second time I've done it. We're going to talk about inheritance hierarchy today. We're going to talk about system sequence diagram and fully developed use case description. This is going to end our discussion of analysis phase. It's a little weird because I'm not in my office, so I hope I don't get connection issues. But if you see me freeze, just put a note in the chat room. It happens from time to time. I sent you to do some discovery on Google Core IoT. So many of you have written to me. I know I haven't got some of the emails answered yet. It was supposed to be challenging. It was supposed to push you to explore a little bit ahead of your project. So this is week 4. We're going to have week 5 and 6, then your exam, and then we're going to start talking about your project. If anybody wants to get their Arduinos and start just playing with Arduino and the Arduino IDE, just to know the piece of hardware, you can do that. Just let me know. I can help you check them out on Wednesdays and Mondays from 2 to 3:30. So if you have seen the device before, some of you have done your undergrads with us, you've done 254, yes, you played with Arduino. So you know the device in and out, you know the basics, good. If you don't know it and you want to play with it before your project, you can get it just like yourself. Google IoT platform is new for me too, but I'm trying to stay ahead of you and get some of the small things figured out before we start the project. I know Arduino really well. I've done multiple projects using Arduino, and I've done the heartbeat rate with another platform. I created an app, but to make it work with Google platform, there are some details that we're going to be discovering together. Again, I'm going to try my best to have everything discovered for you and help you as much as I can. But just so you know, this is a project that will require a lot of persistence. Any questions? I'm going to give you time at the end of this class. Specifically, I want us to look at Anitha's example of activity diagram, and I probably ask some other students to share their activity diagrams on what they understood from the Google Cloud platform. And from what I know, you've focused on different areas, and that's a really good thing. So some of the questions may be answered after we do the demos. I see that one person is missing, but I have a hard time figuring out who that person is. Oh, I know. So we're good. Someone is traveling, so we're good to start. Any questions? I have posted your grades. I fixed the problem on quiz 1. Any other issues with the grades? No? Okay. So we're going to do a lecture and then look at your activity diagrams. And we're going to do another lab on Wednesday. Let's see. I have this one up. Then I have to share my screen too. And then go to present mode. Again, a reminder, work on your quizzes, and we're gonna have a lab on Wednesday. The diagrams that we're introducing today are not the ones that we probably create in GenMy model yet. Who wants to talk about this picture that you see in front of you? Bird, lizard, and a dragon. Some of you have seen that. I use this picture a lot. What is a dragon? Eric, what is a dragon?
Professor, as far as I know, I think a dragon is an animal that is not in existence as we speak now. So many years ago, I think I don't know if it's right or wrong.
So can you confirm that you see the full screen version of my slides?
Yes. So
it
I
connects
see
the
that.
dragon. It connects the dragon to two other things. What are those things?
So I see a dragon connected to bear and lizard.
Yes, dragon is a mystical feature animal. It's in this picture is connected to a bird and a lizard. We call this an inheritance hierarchy. So we call dragon a subclass, a bird is a superclass, a lizard is a superclass. And this is the way to show it. So it has the blank triangle. And what does it mean, Pranav, to have this superclass subclass association here?
It means that what I feel is that the dragon's characteristics are there in the bird and the lizard.
What does the superclass subclass association mean? How many different attributes do I need to describe an instance of a dragon? So dragon has a name and capacity. Does it have anything else, Pranavi?
It has types, Professor.
Type?
Like there might be different types of dragons.
Just based on this picture.
Oh, sorry.
This is a funny conversation, and it's a good start. We all need some fun. So when you do inheritance hierarchies or superclasses, subclasses, a subclass will inherit attributes and it will inherit behavior. So what are some of these implications, Daniel? You've seen this example before. What's a dragon?
I thought we just said the dragon is the subclass.
And so how many?
It can also have like the maximum speed, wingspan, and then the number of claws and the scale colors.
Exactly. So you inherit a subclass inherits attributes of the superclass. So a dragon here has maximum speed and wingspan inherited from bird, number of claws and scale colors inherited from lizard, and then name and fire capacity that are two specific attributes inside the dragon. Now, behavior is also inherited. Behaviors are those methods in your classes. So in this case, behavior of a bird is flying, and that's going to be inherited by dragon. This is what we call an inheritance hierarchy, a set of subclass and superclasses. And that's going to be something you're going to add to your domain model class diagram. Some of you have already started talking about superclasses, subclasses. You showed me example and you said maybe these two are the same with small differences. Maybe I can create an inheritance hierarchy. And if not, I'm going to ask you to think about inheritance hierarchies for your project. That's going to be related to your domain model class diagram that you created in your lab 2. This is what you did in your lab 3. This is your activity diagram. And the two items that I'm going to discuss in addition to inheritance hierarchies are fully developed use case description table that's at the top right and the system sequence diagram at the bottom. These are the two that we're going to talk about today. A fully developed use case description is a table or a document that details all the issues around a use case. Who are the stakeholders? What's the triggering event? What are the preconditions? What are the post conditions? All the details related to a use case will be shown on a table or on a document called fully developed use case description. And then you have your system sequence diagram, which is very similar to an activity diagram, shows the steps. But in case of system sequence diagram, it shows the steps and the flow of activities between the actor and the system as a black box. When we go to design, you're going to create sequence diagrams. That's when you look into the system. The system will not be a black box anymore. And then you would think about all the objects that do the work and show them on your sequence diagram. But here in the analysis phase, we don't know that much about the design. We don't know the objects and the work that they do. All those details will be added in design, and that's when we can create a sequence diagram. Most of you, if you've done your undergrad in computer science, or if you have work experiences, you've seen sequence diagrams. And I'm not sure if all of you have seen a system sequence diagram, which is the simple version of that. So we're going to talk about that after we talk about inheritance hierarchy. So this is another inheritance hierarchy. It says sales can be of 3 types: online sale, in-store sale, and telephone sale. So which one is superclass? Which one is subclass? So let's see. I need to have your names in front of me. Shivani, which one is subclass? Which one is superclass?
So sale is the superclass and online sale, in-store sale, telephone sales are the subclass.
Exactly. And how many attributes do I need to describe online sale?
Time on site and chat us.
And
Chat use.
that's only 2?
And all the attributes of sale as well.
Exactly. So you have 6 up here and 2 there. All of them together describe an online sale. Good job. Let's ask, is that Churchill? Do I see you, Churchill?
Yep, I'm here,
Yes.
Professor. Yep.
What time is it there? Remind me again.
Yeah, 11.
Wow.
Yeah,
I'm sorry
11
that you
p.m.
have to do this at 11 p.m.
No
But tell
problem.
me, how many attributes do I need to describe an instance of in-store sale?
We're talking about the store ID, register ID, click ID,
And
and
all other attributes that
bits
are
from the super. Yeah.
exactly.
Yeah.
So my hope is that when we get to your project and you really look at real code, you can identify some of these concepts in the written code. You can look here, I see an inheritance hierarchy. There are keywords for that. Yes, something extends another thing in Java. and you can look at the attributes and recognize, oh, this is what I have for this specific class, and the rest comes from the superclass. How many attributes do I need to describe telephone cell? Let's ask Aisha.
Well, two have to be described in telephone sale, and in the superclass, all the six have to be described, Professor Jack.
So 8 total, yes.
Yeah.
How about, let's go to this example. Manasa, where is the inheritance hierarchy in this other example?
Account.
It's an account is a superclass. Saving account is one type. Checking account is another type. Matthew, how many different attributes do I need to describe an instance of the savings account?
So you'd have to describe the savings account, which was interest rate, and everything under account, which is account ID, date opened, and balance.
Absolutely. Let's go to Chingy. How many different attributes do I need to describe an instance of a checking account?
It needs 5 attributes. It's check style, minimum balance, account ID, date opened, and banners.
Perfect. Great. All right. This is another look of your inheritance hierarchy that you saw in the previous example for sale. And you see the attributes. Also, you see some class level attributes. We're going to talk about that later. You see some behavior or methods. If you haven't heard about methods before, those are the things that objects of a class will perform. Maybe a calculation, maybe processing something, or in this case, canceling and confirming email. There are some behavior up there in the superclass. So your subclasses will inherit the behavior or override behavior or define a behavior that's been outlined in the superclass, depending on the type of method that you use or the type of behavior that's been defined in the superclass. What else they inherit is the association. So the subclasses, they inherit attributes, they inherit behavior or methods, they inherit associations. This is another look. This is just the answer to the questions I asked you, and you all had correct answers. Let's look at this example. Where is the inheritance hierarchy or inheritance hierarchies here? So Daniel has talked Churchill, Shivani, Pranavi, Matthew, Eric, Pranavi, Aisha, Manasa, Anitha, it's you. Where are inheritance hierarchies?
It's in the vehicle class with the cars and truck. They're all inheriting it from the vehicle class.
There are subclasses. This is superclass, yes.
Vehicle. And also I see the warranty service record as a subclass inheriting the service record.
Perfect.
Class.
Good job. Let's see who else hasn't talked yet. Kavitha, are you here? Are you not traveling yet?
I traveled on Saturday, Professor. Yeah, so I'm here. Yeah.
Have you got enough sleep already?
No, not really. It's the jet lag, so struggling with it.
Well, good to have you in class.
Yeah, thank you. Yeah.
Do you want to talk about truck? How many different attributes do I need to describe an instance of the truck?
So it is 4 attributes: one cargo capacity and the 3 attributes of vehicle.
Perfect. And Lance, how many different attributes do I need to describe an instance of warranty service record?
You need 3. So you have the attribute inside warranty service record, eligibility verification, and then the 2 that it's inheriting from in the superclass, service date, and current mileage.
Perfect. So good job reading this class. One thing that we have as a principle is that superclasses will stay abstract. It means that they cannot have instances. And this is a principle, not a rule. How do I tell you that? So it can be violated depending on the purpose. If you're a programming language designer, you don't follow this rule. But in most applications that we work with, all superclasses are abstract, meaning that you cannot define instances of them. For example, if you have a superclass that's an account, and you have checking account and saving account, you can't go to the bank and say, just open an account for me. They won't open an account for you. It has to be either a saving account or a checking account or some other type of account if they have them. So you cannot define an instance of the superclass inside your system. So here in the case of animals, you have animal, feline, canine, and hippo. And these classes that have children, they stay abstract. And the classes that doesn't have children, like hippo, dog, wolf, tiger, cat, and lion, they're concrete. It means that you can define instances of them. This principle has so many connections with some of the other ideas that you may have heard in your programming languages classes. So we're just going to keep it simple for now. Abstract, superclasses are abstract. They cannot have instances. And subclasses that don't have any children. So like, for example, a canine is a subclass, but it has children. So it still stays abstract, meaning that I can't go to this system about animals and say, I want to add a canine. The system will ask me, is it a wolf or a dog? It doesn't let me add a canine to the system. Again, in the applications that we see in this class, there are scenarios in which this principle can be violated. One thing that's very important for you to understand is, let me put the definition of while I'll talk. In some concepts can be abstract in your application, meaning that they have subclasses and you have to be very specific what you want. Some of them are, and same concept is concrete in another application. Let me give you an example. I usually give this example in my classes. So maybe, Daniel, you've heard it already. When you are stopped by the police officer and they suspect that you're driving under influence, do they care if you had something, 1997 Pinot Noir or something else? Do they care what exactly you had?
Oh, probably not.
I didn't mean to ask you. I was just asking the whole class, but
Oh, I thought you were asking. I was like,
but good answer. They don't care, and that's the correct answer. So for them, alcoholic beverage is alcoholic beverage, and that's enough information. But if you go, let me ask Kelvin. Kelvin hasn't responded to any questions yet. Kelvin, if you're going to a bar, would you say to the bartender that I want alcoholic beverage?
Once I'm in Teba, Professor, it's obvious that whatever is there is alcoholic. So I will just say maybe I need Jack Daniel's whiskey.
Yeah, you have to be very specific. So alcoholic beverage for a police officer or a police information system is just alcoholic beverage. So it's a concrete concept. You don't need any more detail. You don't need to specify the type. But when you go to the bar, and if there is an information systems that they need to put your drink in it, they need to know, they ask you what specifically is that you want. So it could be beer or wine, different types of cocktails. There is a specific type that says that alcoholic beverage is an abstract concept in the bar. It means that you need more information. You have to go down the hierarchy. Just like Kelvin said, if I go to a zoo and I don't say I found an animal and I want to bring it to the zoo. I have to say specifically what type of animal, and I have to go down the hierarchy to make sure I place this specific animal in the right category added to the zoo information system. So if you need to ask question, what type of alcoholic beverage, what type of animal, what type of food, what type of tree, that means the concept is abstract. That means that you have to provide more information. It means that there would be an inheritance hierarchy and specific types that will appear under the concept. So in this table, yes, questions? In this table, I give you a concept like a tree, a house, town, a football player. And I give you an application, okay? And I ask you to complete the rest of this table. Let's look at the first example, is a tree. In a golf course simulation, let's go from the beginning of my list because everybody has answered the question already. In a golf course simulation, a tree, is it an abstract concept or is it a concrete concept? And remember, if you have to ask what type of tree, that means the concept is abstract. If tree is tree and that's enough information, the concept is a concrete concept. So Shivani, is in golf course simulation, tree is abstract or concrete?
Ma'am, I think concrete.
Exactly. You don't care about is it cherry, apple, ornamental, or what type of ornamental. It's just a tree you're simulating and you want to see where the ball goes and how to give points. Is it tree or is it grass? That's just enough information for the simulation. How about for tree nursery application? Do you go to a tree nursery and ask them, I want a tree?
Then at that point, I have to specify which tree I want. So that will be an abstract class.
Exactly. Exactly. So I'm going to give you 5 minutes. You're going to read the 3 concepts and you're going to look at the application I have given you and ask yourself, is this concept concrete or abstract in this application? If it's concrete, you have to give me an application for which the concept is abstract, and vice versa. If it's abstract, give me an application in which the concept is concrete. 5 minutes. Any questions? Who wants to go with a house?
Professor, let me go.
Go ahead.
With an app known as Zillow. Zillow is Zillow. That is used to value houses. The house can be an abstract, and the architecture application here can be concrete.
So you named an application in which the house is abstract.
Yes. The application is Zillow.
Okay.
Zillow app.
Is it really abstract? So the price only depends on the house attribute, not the specific type of house. I wonder if they consider attribute. But we can ask your classmates to comment on that. So Zillow, Churchill is suggesting that for Zillow, a house is just a house, no further classification. Maybe depends on the valuation of the house, but I thought the valuation depends on the type. Somebody else probably knows more about housing valuation than I do. In an architect application, Churchill, is it abstract or concrete?
It's an abstract.
It's abstract, yes, because you need to know what type of house. You just don't go to your architect and say, design me a house. So anybody else came up with an application in which house is concrete? No? Pranav, what did you come up with for a house?
I feel it is abstract because there can be different types of houses, and if you say
yeah, it's abstract, but give me an application in which a house is concrete.
If a house is concrete, okay. Okay, there's an app called Airbnb where
that's also not concrete because you have to see, is it a house, a ranch, or a duplex, or a condo? There is not just a house. I don't think so. Do you think so? Class, discuss. Do you think house is just a house in Airbnb?
No.
You think it's abstract? Yeah, I think the same. For town, a town in a satellite photo application, is it concrete or abstract?
I think it's abstract, ma'am.
When you look at satellite images, do you care about the type of town?
Yeah, if we need to specify, right, ma'am? It's a particular town. We want to view the satellite of a particular town.
No, if that's not what we mean by abstract versus concrete. So when you look at the satellite images, you just want to say, this is a town, this is a road, this is a jungle, this is a mountain. So probably you wouldn't care about a house.
What type of town or something? Oh, okay.
What you say, a town is abstract. Where is it that the town is abstract?
I took off, I saw in the front of Maps app saying, if we specify it and a particular details about a town will come, correct? If you specify in an app, in a Maps app or anything, if you want to have a satellite view of anything, of a particular town.
Like when you say, I look for a town, would they ask you what town, or
Yeah, we need to see. As I'm saying, as per my understanding, ma'am. So if you open a Google a maps or something, it doesn't show us anything, right? We have to specify what town we want to see the satellite view.
That's, you know what, a town and the name of the town is an attribute. But
Okay.
would you say what would it give you options for different types? Probably not.
Yeah.
But in government applications, usually a town has some features, and towns have different types. If you look at, for example, normal Illinois on Wikipedia, there are some attributes that it tells you it's there is an inheritance hierarchy. So not all towns are the same when it comes to government application and different governmental policies.
Okay.
Football player in a coaching application, is it abstract or concrete?
That will be abstract.
It would be abstract, yes, because it matters what kind of player you are dealing with. Where, in what application would a football player be just a football player and that's enough information?
Maybe an app that gives data on the number of players in a certain league.
Number of players in a certain league, that doesn't care about the type of player. Just player is a player.
University maybe, ma'am. Where
What?
in universities when they offer athletic scholarships, they just address them as football players, not their specific positions. They just call them student athlete, football player. That's it.
Exactly. So that's an example of a system that wouldn't care about the type of player. So that was a good activity for concrete versus abstract. And I think some of your ideas that you had at the beginning, maybe if they were unclear, I hope that you have a clear idea here. But when we get to coding and you see actual programs, we probably make more sense of these concepts that we discussed in lectures. This is what we call a use case description. So just so you know, I ended the discussion of inheritance hierarchy. I'm switching gears. This is another piece of document that we usually produce during the analysis phase. We call it fully developed use case description. Most of you have seen one version of it. For some of you, it's new. So I'm going to go over the items, and maybe at some point during the semester, I ask you, when you worked on the project, I'll ask you to create a fully developed use case description and to come up with all the surrounding issues of a given use case. So there is a use case here. This is add a new resort. This is a resort management system. The resorts publish their availabilities, and students reserve accommodation for their spring break. The case study comes from a book that we use as an undergrad text in this school. The case study's name is Spring Breaks or Us, and they have a few of these fully developed use case descriptions. I use their examples. There are a few more that I may show you during the semester. But basically the idea is that some resource, they share their availabilities, they sign up for this program, and then students on the other side, they reserve accommodation for their spring break. So this is the name of a use case. This is the name of a scenario. If there are different ways of doing the same things, you have scenarios. For example, if you wanted to go shopping, you can shop online, shop on the phone, or shop in person. Those are different scenarios of the same use case. So if you have multiple scenarios, in fact, you will need multiples of this table. But let's say there is only way to add a new resort, and that is how it happens. I'm going to just show you. That is, let me just have the names list on the side here. A new resort contracts with us SBRU to participate in the vacation program. And there is a description. The people who are involved are the clerk from Spring Breaks or us, SBRU, and the resort employees. So two people talk, they want to get a resort on the system. The stakeholders are the management of the company who does this service and the resort management. Preconditions, post-condition, and flow of activities are the areas I want you to focus on. Why? Because in many of your use cases, it is very easy to find out who the stakeholders are and who the actors are, and what triggers a use case. Now, you just have started to understand some of the areas. So you played with a few systems so far. You have a basic understanding for Google Cloud Platform, let's say. Maybe at this point in time, you don't know different scenarios or different use cases or different stakeholders. But probably after a few weeks visiting the platform, doing programming, doing projects, you will have a good understanding on who are the users of these features and who are the stakeholders and what is it that the system does when it delivers this specific feature. So when I say it's easy to come up with, the most appropriate thing to say is that it is relatively easier. So it's relatively easier to come up with this first half of this table. But when it comes to preconditions, usually my understanding is that students, they have difficulties. What are preconditions? Let me have some arrows up here. Preconditions are about the state of the system. How do we define the state of the system in an information systems platform? By the data that's stored, yes? So usually it's about the state of your database. What's in the database? What should be there for the use case to be able to start proceeding? Post conditions are the opposite, are the things that should happen after the use case is completed. Even if I'm going to tell you this with a lot of certainty, even if you may not see the rest of this piece on your future project, I'm very confident that preconditions and post-condition, maybe not under these labels, under other labels, they show up in your projects. So you should have a really good understanding on what the state of the system should be for a user to access this feature and proceed smoothly. In this case, they say resort must not already exist. So for someone to add a resort, the resort shouldn't exist in the system. If it exists, the use case will stop. You get a message, the resort already exists, and done. Post condition is what happens after you add a resort. Again, it's about the state of your data, what your system needs to know after the use case is completed in order to remember that something has been done. So in this case, they say resort is created, facilities are created and associated with the resort, accommodations have been created and associated with the resort. So preconditions, post-condition. Even if you don't see this table, you have to have a really good understanding on preconditions and post-conditions for your projects and the features you're working on. And then it comes to the flow of activity, which connects to the next topic of our discussion today. It shows the steps. So the first step is verify the resort doesn't exist. Check the database, enter resort description. The system creates the record. And then loop through facilities, loop through accommodation, and create records of those in the system. So for you, this this flow of activities is completely new. But let's say I was the business analyst and I came up with this list. I said to add a resort, this is how you do it. First, verify the resort is not there, and then add the resort information, add the accommodations, all of them, add the facilities, all of them. And then, of course, the system will terminate the process if the resort already exists. So preconditions, post-condition, some of the areas I want you to pay attention to, and this is the first time you're seeing it. I'm gonna show you more examples in the future and ask you to think about those. Also, when you work on your project, I will ask you about preconditions and post-conditions. Have those two keywords in your mind and try to ask me questions about them, try to make sense of them when I introduce the projects. A flow of activity is something that we can show in an activity diagram because it's a list of steps. So this is the activity diagram that goes with it, the visual representation of the same thing. So search for resort. If you found, end it. If you don't find, enter resort information, create the record, enter facility, there is a loop, create records of the facility, enter accommodation, and create records of accommodation. Sense of it. Except for the decision node that they chose not to use the diamond, and this was one of the two options. If you remember, I showed you a list of symbols. Choosing a diamond is one option. Choosing just a regular activity is another option. So they use this, and they use the synchronization bar for the loop. You can use fork and join in your GenMyModel platform. This is the one area I want probably to spend most of the time on because I'm going to visit this again during design. And this is a pretty important part of UML. And most of you have seen sequence diagrams. This is what we call a systems sequence diagram. So the systems, you look at the system as a box, appears as a black box. We don't know anything about inside the system. That's the key. And the steps are the same steps shown here, same steps shown here. This is just another visual tool. So nothing rocket science here. Flow of activity shown in another form here on a system sequence diagram. What is the difference here? This is a pure UML diagram. So 10 years ago, or maybe 20 years ago when I was in college, activity diagram was not part of UML yet. So if you wanted to model flow of activities, you have to use a system sequence diagram or a sequence diagram. Over the years, UML has adopted activity diagram, and that's what you did for your lab 3. That's what we did last time. But this is a pure UML diagram. It means that everything should somehow connect closer to the code, object-oriented code. And for that reason, the name of the labels are the name of your methods. So here, you see the first message and the label for it, it looks like a method signature. So again, 20 years ago in college, when I was doing system analysis and design, we used rational rows. And at that time, it wasn't part of IBM. So we would create these diagrams, and the rows and rational rows would give us a walking skeleton of the code. So when we put a signature here, there would be a method added to our class somewhere that has the same signature. So it would help us. Of course, nobody ever used the code, but we had the option to use it because the code at that system was not very well designed. But it was connected, and we would get a walking skeleton with these methods. So labels of the messages sent are phrased like method signatures. And then you see the same logic. I send a message to the system, I get a response. Here, I send a message or I do something, the system does something. Here, I ask system to do something and it gives me something back. So in this case, I'm searching for a resort with a name. That is a method inside the system. Which object, we don't know yet. And this is what we get back. Then the next message is create resort. The star shows the loop, create facility with those parameters and create accommodation with these parameters. So a system sequence diagram, an alternative way of showing the steps required to complete a use case. It's a pure UML diagram. The way it uses symbols and labels is supposed to help you with your coding. And in this specific example, you see search for resort, create facility, and create accommodation as three methods that will be inside your system somewhere. Any questions about system sequence diagram? No? Go ahead, read this one, and then we're going to end our discussion, and then we're going to revisit the same concepts again soon. Go ahead, read this one, and try to describe in plain English. Who wants to describe this?
Hello, Professor.
Go ahead, Churchill.
Um, this more like a resort. Let's say, example, I want to make a reservation for a resort using an online, let's say a mobile device or from their website. I search from the system. Then the system will give me the list of the resorts available. Then I pick one. I proceed, then I check for the availability. Then I proceed after the availability, then I proceed with the details.
Exactly.
And then, yeah.
Good job. So if you imagine this as something on your app, and the steps that you are required to follow in order to complete your reservation. That's a really good metaphor. Just think about the features that you're seeing as something on your app, the feature, and see what kind of steps you follow. So this is what we did today. We talked about inheritance hierarchies, and I will ask you questions about that in the lab on Wednesday. We talked about a fully developed use case description, preconditions, post-conditions, and flow of activities. Then we talked about something new, and that's your system sequence diagram. There will be a chance for us to practice these again and see them again. But before we get there today, and I know some of you have emailed me, were having doubts about your lab 3. It's okay, whatever you have submitted should be good. If I didn't get a chance to respond to you, because Mondays are my busy days. So I'm gonna see some of you. I'm sure Anita has something to share. So we're gonna give Anita 3 minutes, and then I'll ask for 4 more volunteers. Okay, so if you have an activity diagram, you like to talk about it, we like to see it. Go ahead, Anita.
Okay, ma'am. Can you able to see my screen, all of you?
Yep. A little, can you make it a little bit bigger, zoom in?
Okay, just a minute, ma'am. I open in the editor.
That's okay.
Something's up, sorry.
That's okay.
Okay. Ma'am, yeah, I got it. So this is about a Google Home system. I have created the activity diagram. So what I did is the user first is the one who initiates initiates the command. He gives the command to the Google Assistant. The Google Assistant first checks if he's an authorized user. So if he is an authorized user, he validates, I mean, the Google Cloud. It directly goes to the Google Cloud and authorizes all the user details here. And the Google Cloud gives a response to the Google Assistant, and Google Assistant says that it checks, I mean, it then verifies if he's a authorized user, or if he's not an authorized user, it says that you are an unauthorized user, and it stops the activity. If the user is an authorized user, and he, as we also already know that the user gave a command, and it checks is whether it's a voice command or not. If it is a voice, it's not a voice command, it just type the text. And if it is a voice command, the Google Assistant has a speech transition, and this voice command is converted into text. And both these commands, no matter what you give the command, they go to the smart home int. And this is the app which monitors all our home devices. That's the lights, all the ones which IoT functions to be performed. And this home init app, intent app, it again sends a request to the cloud, Google Cloud, to perform the command operation. And this Google Cloud, it processes the command, it sends a response to the Google Assistant, and Google Assistant gives a speech response saying that the task is completed. And when the command is processing, it also checks it whether it is a simple command or not. The simple command in the sense means just turn off the lights or so. So if it is simple command, the Google Cloud, it performs the operation on the IoT device, just like turn off the lights in the bedroom. So it does it, the lights. If it's not a simple command, that means opening the security door or opening the door of the house, in that it again sends a confirmation pin to the user, and the user again sends enter the details and everything. And why this run authentication means, it's a call behavior means the process of this authorization and everything is going on again and again. So once everything is done, if it is all correct, it again performs um, it on an IoT device and again sends a response and it stops. Well, this
I,
is
I I really like this one because it shows the process perfectly. Also, she has chosen to have that include. So instead of describing the whole authentication process, she calls another use case, and there should be another diagram that explains that process. So she has put that part separately, and then she's had all the swim lanes related to this specific feature, and all the decision points, everything shows perfect consistency with reality. Anybody else wants to share their activity diagram? What you have focused on different areas, so that's okay. Whatever area you have focused on, your area might be different from that of Anita's. Who wants to share?
And can I share?
Yeah, I think that's a good idea. Okay.
I think yeah.
All
So
right.
I just work on how to connect to IoT devices using the cloud IoT core.
Mm-hmm.
So here what we are doing, so first IoT devices send an message to core bridge to pub or sub device, and that this device will go to the cloud IoT to authorize the client if that device is authorized or not. So if it is not an authorized device, it will just terminate the process. If it is an authorized device, then it will go for further steps to generate the configurations. So it will just change the parse the message, then increase the hoop counter, which is inside the core of the cloud. And then after increasing this counter, that it will generate the configurations for the device 2. So after this, these configurations will be sent to device 2, and it will receive the new configuration. It will receive the configurations. Once the configurations are received, now it will check if the device is registered or not. If it is registered, then it will go for the further process. If it is not, then it will ask them to get the device registered using the generator key peer, and then using the public key to register your device. So once this registration is done, and if it is already registered, then it will go to this change the configuration. It will give an option of change the configurations. So once we have changed the configurations on device 2, both the devices are like they will be communication between the two devices will be set up.
Perfect. This is really good. And I know you had emailed me, I think, before the deadline. I didn't get a chance to say this is really good. Probably only one area I would change. I would have different swim lanes for IT core bridge or pops up, or I put them inside the cloud platform as a whole. So I just them appearing under device 1. Mm, that's the only thing I would change, but everything is perfect. And don't worry, you don't have to change it now. This is iteration 1. So there is chance for us to revise this after we do our project and we figure out some of the details. But for me, just the two, core bridge and pops up appearing under device 1 swim lane. Just, you know, because they're different entities. That's the only issue I have. But everything else looks good. Who else wants to share?
Thank you, ma'am.
Who else? Pranav, what did you do?
Yeah, just a moment.
And then maybe Matthew, you go because you also emailed me about your activity diagram. And I thought it was a good example too.
I'm just trying to get the screen ready.
Sure. Anybody else is volunteering to share their activity diagram? Is it starting to make sense little by little? Daniel, you want to share?
Yeah, mine's ready. No.
Okay, go ahead. You share.
Okay. All right. So mine, I did mine about, so I just got a new weight scale that has an app on my iPhone. I think it's called Fit Track or something like that.
Okay.
So it gets the weight from the phone or from the device, sends it to the phone, and then the phone keeps track of like all types of information in the cloud and then sends that back to the app.
Nice.
Oh, yes, how I understood it. It's kind of complicated. So let's see. So to begin with, the user logs into the phone app. The phone app then accesses the cloud app, which I think Google, like AWS calls it cloud compute, but like where the app is computed at.
Sure.
From there, that cloud app would then access the cloud database. So it would say, hey, get Daniel Freeberg's information, sends it back to the cloud app where everything is then calculated. There's like 10 different things just from one scale. And then that data, that chart, and then would then go back to the phone and is displayed. So it says like, oh, last month you gained 1 pound, but all types of other stuff.
Sure.
So after that is displayed on the phone. So that's all before even stepping onto the scale. So now we think that, so now after we get the data, the user steps onto the scale over, and this is when we first get anything, or we interact with the weight scale device. So once we step onto the scale, that data, rather than sent to the cloud or to the cloud, it's sent to our phone because our phone is right there. Then our phone sends that back to the cloud app. And then here I've kind of got it split where the cloud, so that new data would just be sent over and stored to the database. But the new data could also just be already added to the last month's weight and then displayed back onto the phone. And then when the user logs out, we log out of the cloud app, log out of the database.
Sure, that is like live data feature that as soon as you change it here, it shows the changes over there. So this is really good. So this is assuming that your app runs on Google Cloud Platform, yes?
Yeah, well, I know it's running on some platform because it's not storing all that information on my phone. So
yeah, I really like that you pick an area that you have experience with. So you see the features, you see the impact on your side, and you try to make sense of what happens behind the scene. This is really good. And you know what? If you realize something later and you wanted to modify some of these steps or the sequences, you can always do that. But really good start. Who wants to go next? Anybody wants to go next? Anybody's ready?
So Niku.
Sorry, sijawahi.
It's fine.
Kelvin, you want to go? Or Pranavi, Matthew, who's ready to go?
I'm ready to share if you want me to.
Go ahead.
So I did mine on a little bit more abstract feature that Google has called Google Cloud Functions, which allows you to actually execute functions for IoT devices without having specific hardware dedicated to running those functions. So you can run Python, Java, or anything you want to actually run functions on other servers, such as data storage or executing other features that you want. And the reason why...
Can you zoom in?
Sure, I think I can. So what really drew me to this was that they have a built-in authentication method for actually processing this. So with a lot of IoT devices, they're not really secured. So a lot of hackers actually look into finding ways to actually hijack these IoT devices and processing the data, or actually overwhelming servers for they're actually taking in the data. So with this left-hand side, I got IoT device that sends an HTTP trigger, which contains the contents of what the variables that is trying to be processed. And with Google Cloud Functions, it actually sends a SAML authentication request to Google Cloud IAM, which is authentication method that Google has, and basically verifies whether or not it's if the credentials are correct and the device is who it says it is. And if the device is authenticated, they'll perform the specific function that is designed for whatever you specified it in processing those variables. But if it's not, it'll actually drop the packet and pretend that it just did not receive it. That way, hackers do not keep trying to get into the system. But after it performs the function, it'll actually send a process data that it receives as output back to the IoT device.
Perfect. So with Matthew's example focusing on security, Daniel's example focusing on the system or the app he's familiar with. Anita's example focused on the smart home, and Shivani's example focused on the connection of two devices. Really diverse set of activity diagrams covering different areas of this platform. I loved hearing and seeing your descriptions. So this is the first iteration. If we realize something requires modification after we practice and learn more about the platform, we can always do that. So well done, everyone. I'm going to look at the rest of them on the assignments that you have submitted. For Wednesday, be prepared to do some lab exercises with me, and just check your quizzes and your readings, and enjoy the rest of your evening. Take care. Bye.
Thank you. Thank you. Bye.
Bye. Good job, everyone. Bye.
Thank you. Bye-bye.